Hello, I welcome you all in this video lecture. I am going to discuss about the mechanical property. So there are 15 types of mechanical property I am discussing here. So why what is the mechanical property? Mechanical property is the mechanical behavior of the material when the load is applied. For designing the machine component, the knowledge of mechanical property is necessary. So for any engineering material, the mechanical property are determined by using some testing methods such as universal testing machine, impact test, and creep test. So this is all about the mechanical property. Now one by one we will discuss about the different types of mechanical properties. So this is the strength. So the maximum what is the strength here? Maximum stress sustained by the material is called strength. For ductile material, yield strength is the strength of the ductile material, while for brittle material, ultimate tensile strength is the strength of the brittle material. So for designing of machine component subjected to static load, yield strength and ultimate strength is used. Second one is the ductility. Ductility also property of material. So the definition is ductility is the property of material by virtue of which by applying the tensile load on the material it can be drawn into the form of wire without fracture. So the word without fracture is important here. Without using this word without fracture, the definition of the ductility is incomplete. So example of this ductility is mild steel, gold, silver, or ductile material. Third one is the elasticity. Elasticity is the property of material by virtue of which the material regains its original shape and size after removal of external load from the material. Example, rubber band and steel are the elastic material. Fourth one is the malleability. This term malleability is nothing but the property of material by virtue of which the material can be converted into the form of thin sheet without crack propagation or fracture on the surface of material. So red line is important. Without this red line, the definition of malleability is incomplete. So for example, we can say gold, silver, lithium are malleable material. Fifth one is the machinability. How easily the removal of material take place from the surface of the material by using the some cutting tool is called machinability. If machinability is good, then the material can be easily converted into the desired shape and size. For example, brass, aluminium, mild steel, copper are good machinable property. They have the good machinable property. Sixth one is the toughness. Toughness is the property of material that the material withstand the shock load without fracture. The modulus of toughness can also be determined by area under the stress strain diagram up to fracture point. The toughness is important for the hammers and cutting tools. So hammers have the higher toughness. For example, steel is a tough material. Seventh is the brittleness. Brittleness is a property of material that the material breaks into numbers of the part without any plastic deformation. So if material has the brittleness, so it there will be no plastic deformation. Yes, there will be deformation, means material will break into number of the parts, but there is no plastic deformation. So brittleness is the opposite to ductility. So the failure of the brittle material is due to crack propagation in the material when the load is applied. Example, glass, ceramic, cast iron, bricks and stones are brittle material. Seventh is the stiffness. Stiffness is also a property of material that resists the deformation of material. Stiffness can also be defined as the load per unit deformation. So stiffness K is equal to load applied load F divided by deflection delta. So best example is springs, and second one is the steel. Steel has higher stiffness. Now resilience. Resilience is the energy stored in the material without yielding. So best resilient machine element is spring. Spring has the resilience property. It absorbs energy before yielding and release. after the load is removed. Example, spring is the best example of resilience. Hardenability. Hardenability and hardness both are the different thing. Hardenability is the property of material that how easily the formation of martensite take place in the material is called hardenability. Hardenability is more means material can be easily hardened. Hardenability is determined by geometry and quench test. Hardness. Hardness is the property of material that material resists the scratch or indentation on the surface of material by using some standardized object or tool. So red line is important here. By using some standardized object or tool. So hardness is the surface property and be determined by some tests such as Brinell, Rockwell, Vickers and Noob test for hardness. Endurance strength. Endurance strength is the property of material that the material can sustain the completely reversed loading for infinite number of cycles without crack propagation of the surface on the material. Endurance strength is determined by fatigue test. Creep. Creep is a property of material. So, definition of creep is slow and progressive deformation of material under the action of constant load and temperature having more than the recrystallization temperature is called creep. Creep is a property of material. So, creep can cause a component to deform so much that it can no longer function. Example, deformation of the turbine blade and it touches the casing causing to blade to fail because here the turbine blade works under the higher vibration as well as it has a temperature more than the recirculation temperature. So due to higher temperature, as the time passes, the turbine blade length just increases. So it causes to the failure of the turbine blade because it touches to the turbine casing. So just it touches the turbine casing, it become fail. 14th is the plasticity. Plasticity is the property of material that the ability of solid material to permanently deform or change the shape under the external load is applied. If material has good plasticity, the material will not regain its original shape and size and deformation will be permanent. 15th, and it is the last slide, fracture toughness. Fracture toughness is also a mechanical property. So fracture toughness is the ability of material to resist the propagation of crack when the load is applied. This mechanical property is determined by I-Jordan Charpy test. So this was all about the mechanical property. So thank you so much for watching this video. You can subscribe my channel and you can share this video. Thank you so much.